In today's short presentation, we'll be talking about harnessing the power of time series databases and OpenTelemetry to uphold SLOs. My name is Anais Dotis-Georgiou, and I'm a developer advocate at Influx Data. And if you enjoy this presentation or have any questions around time series data or SLOs and leveraging time series databases, I encourage you to reach out to me on LinkedIn. So the agenda today is to first cover what InfluxDB Cloud powered by IOX is. We'll just refer to it as InfluxDB Cloud for short. And then we'll give an introduction to InfluxDB Observability, which is just a demo that leverages Jaeger, Grafana, Hot Rod, and Telegraph to demonstrate how you can collect logs, traces, and metrics all within InfluxDB, and then visualize them in Jaeger or Grafana as you see fit. And then last but not least, we will talk about learning resources that might help you explore these topics more. So Influx Data is the creator of InfluxDB Cloud and Telegraph. InfluxDB Cloud is a real-time monitoring platform for time series data, metrics, events, logs, traces, etc. And Telegraph is an open source collection agent for metrics and events. And InfluxDB Cloud has a new storage engine, and the storage engine is built with Rust, Apache Arrow, Data Fusion, and Parquet. And it was built on these technologies essentially because, well, Rust offers really fine-grained memory management. Apache Arrow is another way for defining in-memory columnar data, which offers even more memory advantages and allows InfluxDB to be more performant. And Arrow Flight is a new general-purpose client server framework that is used to simplify high-performance transport of large data sets over network interfaces. And it was originally developed, or some of the inspiration for developing it was to be able to transport pandas data frames more quickly back and forth between various tools. And so with that ability comes more interoperability with machine learning tools and data science tools. And so basically, InfluxDB Cloud has been built upon the Apache ecosystem to offer really high interoperability with a bunch of visualization tools such as Grafana, Superset, Tableau, and Power BI, and more to come, as well as offering interoperability with other tools that allow you to perform various machine learning tasks, and do this with very high memory management and very high performance for really, really high ingest of data. And so now I want to talk about InfluxDB observability. So this is a demo that showcases how you can create logs, traces, and metrics and send them to InfluxDB with Telegraph, but using the OpenTelemetry standard, and then visualizing those traces both in Jaeger and visualizing logs and metrics and traces in Grafana to monitor your application and actually deliver on any SLOs you have. And this repository is really just meant to be used as a reference for converting observability signals to and from an InfluxDB schema. So the idea here is that you want to be using InfluxDB to store all of your monitoring data and then send them to the visualization tools of your choice so that you can correctly and efficiently monitor your application, create alerts on it, and then also uphold your SLOs as a result. So in more detail, this is essentially the idea behind InfluxDB observability. Basically, we have this Hot Rod application, which is a sample application that consists of several microservices and illustrates the use of Open Tracing API. It can be run standalone, but requires Jaeger as a backend to actually view the traces. And then we send all that data to InfluxDB, and we also visualize some of the metrics and events and logs in Grafana as well. And we use Telegraph to write that data to InfluxDB. Remember, Telegraph is that open source collection agent. It's plugin driven, has over 200 input plugins. So if you have the task of like needing to get data from one input source and writing it to an output source, and you want a lightweight agent for it that's open source, that rhymed, that was fun. Go ahead and use Telegraph. It's worth checking out. So I also wanted to give just a little bit of some context around why we're using OpenTelemetry. And the idea here is that we're going to take advantage of OpenTelemetry because OpenTelemetry is an observability framework that provides a unified way for collecting, processing, and exporting telemetry data like logs, traces, and metrics from an application or any service. And it aims to simplify the instrumentation and integration of multiple monitoring tools through the standardization. So that's the reason why we're adhering to this OpenTelemetry standard, and that's the advantage of doing that. So Hot Rods is the demo application that Jaeger built that we are borrowing here, and it consists of several microservices that illustrate the use of using Open Tracing API. And some features of the application include discover the architecture of a whole system via data-driven dependency diagrams that exist within Jaeger. You can view requests and timeline errors and understand how the application works. You can find sources of latency and lack of concurrency, and diagnose inner request contentions, and etc. So that's also the advantages of Jaeger. And for example, you can look at dependency graphs within Jaeger. So just some context, Jaeger is a distributed tracing platform, and it's used to monitor, troubleshoot, and understand the behavior of microservice-based applications. And we can use, architecture dependency graphs like this one to visualize the relationships between different services within a distributed system, and it shows how they communicate with each other. And dependency graphs like this help people to uphold service level objectives by allowing people to identify bottlenecks. Visualizing the dependency between services. It can help you identify the performance bottlenecks, helps you find error detection, latency tracking, capacity planning, and even perform root cause analysis. When an SLO violation occurs, the dependency graph can then help with the root cause analysis by pinpointing the problematic service or interaction responsible for this violation, for example. And improved collaboration, right? That's kind of self-explanatory. So by leveraging, Jaeger, you can help meet your SLOs by understanding the distributed system, identifying potential issues, and taking proactive steps to ensure that you are in fact meeting your SLOs. And the same thing goes for, graphing metrics and logs in Grafana, for example. Grafana and Jaeger are both popular tools for monitoring and observability, but they serve slightly different purposes. Jaeger is designed more for distributed tracing, whereas Grafana is more general purpose, and it's flexible in its visualization tool capabilities, and it can handle, logs, metrics, and traces. And some other benefits is that you can, get data from multiple data sources. So while you might be storing all of your metric, event, log, and tracing data within InfluxDB, and then visualizing the appropriate data in Jaeger and then the appropriate data in Grafana, maybe you also have relational data that you need to be pulling in for some root cause analysis work. All of this monitoring is required, though, to ensure that you can, in fact, uphold the SLOs that you have agreed upon. And additionally, you can perform alerting within Grafana as well. So that's another popular feature that people use to help set, alerts based on thresholds or conditions in your logs, metrics, or traces to proactively monitor your system and respond to issues before they become critical. So in order to run this demo, which I encourage you to do to really get a feel for the advantage of having a unified location, a data store for all of your time series data in InfluxDB Cloud, which you can also query with SQL, which is easy and fun, is you essentially create an InfluxDB account. You do some sort of administrative work before, which includes creating 2 buckets or databases where you want to include all your logs, traces, and metrics in. You create an env file with some authentication credentials. Then you do some installation steps as per the README. And you can import the dashboard that I showed previously with a JSON file into Grafana, and just simply create traces by running that Hot Rods application and clicking on a customer to generate them. So it's really just kind of as simple as that. Last but not least, I wanted to share some resources that you can use to learn more about InfluxDB and this demo, and how it can help, how InfluxDB can help you maintain and uphold your SLOs. I encourage you to view or ask any questions on the community forums, Slack, GitHub, of course, and then docs, and also we have blogs and InfluxDB University for free courses. Thank you so much for your time. Have a great day.